further, but let's focus on the applying the product rule. Okay, let's take a look at something slightly different. And we're on example 6 now. And we want to differentiate y equals e to the 5x ln x. Let's go sine x rather than ln x. Let's go e to the x sine x. We want to differentiate some trig, plus 6x squared. Okay, now this is slightly complex, and the reason why it's complex is because you are looking at applying the product rule here and then differentiating something as you would normally differentiate in the normal way. Okay, so let's take a look here. So the first part, in this part of the question, I am going to be using the product rule, and in this part of the question, I'm going to be differentiating as normal. So let's start by this bit here. Let's apply the product rule. U equals one of the functions. E to the 5x is a function of x. Sine x is a function of x. So you go, let u equals e to the 5x. It follows that v is equal to sine x. Okay, du by dx is e to the kx differentiates into k e to the kx. And then we find dv by dx. And from the diagram we have used before, this is sine cos minus cos. And in this case, we're differentiating sine, so the sine differentiates into cos. So this is equal to cos x, or differentiates into cos x. Okay, now let's go back to our original question and let's differentiate here. So we're finding dy by dx. And I am differentiating this part here of the question and then plus the derivative of this part here of the question. Okay, so let's write the first part. Here's my cross multiply. So for the first part, I am going to have 5 sine x e to the 5x. I think I don't like writing it this way. I'm going to write 5x, the e first. So e to the 5x sine x. It doesn't really matter. You could have used brackets if you wanted to. So 5 e to the 5x sine x plus e to the 5x cos x. And that's the derivative of this part here. Okay, and then I'm going to go plus the derivative of 6x squared. And in this case, you drop the power, so 6 times 2, which is 12, and then decrease the power of the x, so 2 minus 1, it gives you 1. So it becomes 12x. And that is the derivative of my function. Again, you can simplify it if you want to. Let's take a look at question 7. Y equals 4x ln 3x plus 2. Okay, again, this is quite a complex example. Why is it complex? 4x is a function of x, so this will be u. Now, ln 3x plus 2 is another function of x. Okay, so u should be 4x. V should be ln 3x plus 2. Now, how do we differentiate u? du by dx is equal to the power of x is 1, drop the 1, and then decrease the 1. So 1 minus 1 becomes 0. X to the power of 0 is 1. So you end up with 4. Now, differentiating this bit, v is a little bit complex. I am going to use the chain rule in order to differentiate v. So I'm going to let pick any letter. Let's go for A. Let A equals 3x plus 2. We're using the chain rule. you can watch my video on the chain rule and it will help you with differentiating this part. Let A equals 3x plus 2. In this case, V will be equal to ln, this bit is A, so V is equal to ln A. One more time, we are going to let the bracket equals A or any other letter you want. Therefore, V is equal to ln the bracket, and the bracket is A, so it's ln A. Okay, let's differentiate dA by dx. We're differentiating with respect to x. And in this case, you get a 3. 3x becomes 3 plus 2 disappears into 0. And then you differentiate dv by dA. You're differentiating with respect to a, because we don't have an x here, do we? So you can't differentiate with respect to x. And that is equal to 1 over a. Now with the chain rule, dv by dx is equal to, if you watch the video on the chain rule, it will tell you that it's equal to 3 multiplied by 1 over a. So dv by dx is equal to dA by dx multiplied by dV by dA, which means it's 3 multiplied by 1 over a, and a, oops, sorry, and a is equal to 3x plus 2. Okay, because earlier on we've let a equals 3x plus 2. So let's apply, go back to our original question, and we're applying the cross multiply here. So it follows from here that dy by dx is equal to 4 ln 3x plus 2 plus 4x multiplied by 3, so that's 12x, multiplied by 1 over 3x plus 2. And that is the answer to the derivative of 4x ln 3x plus 2. Okay, let's take a look at something slightly different. If you feel I'm going too fast, you can always replay the video, stop it at any point and repeat what you want to listen to. Okay, I'm using the product rule in this case, y equals e to the 3x cos 2x. And why am I using the product rule? Because it's a function of x multiplied by another function of x. So I'm going to do exactly what I've been doing for the last 15 minutes. I'm going to let u equals e to the 3x, let u be one of the functions of x, let v equals cos 2x, differentiate u by dx, and when you differentiate e to the kx, you end up with ke to the kx. So you end up with 3e to the 3x. Okay, when you differentiate dv by dx, okay, so cos kx, okay, let's draw the our diagram again, sine cos minus sine minus cos. We're differentiating cos. When you differentiate cos, you get minus sine. Okay, when you differentiate cos kx, you get k minus sine minus k sine kx. So you're going to get here, to differentiate cos x, I'm going to get minus sine 2x. But I'm going to get a k here, and k is 2. So it's minus 2 sine 2x. When you differentiate cos kx, you get minus k sine kx. And then we use the cross multiply. So dy by dx, which is there, and that is equal to 3 cos 2x multiplied by e to the 3x. I like to write the e before, but it doesn't really matter as long as you can use brackets or you can use multiply sign. I think I've messed it up. I'm gonna rewrite it again properly here by going 3 e to the 3x cos 2x minus 2 e to the 3x sine 2x. And again, you can take e to the 3x common factor, but yeah, let's leave it for now. Let's take a look at something slightly harder. And we are going to look at, I think we're on question 9 now. And let's take a look at y equals a trig multiplied by another trig. Sine 3x multiplied by cos 2x. Where do I start? Same as whatever I've been doing before. So u equals one of them. V equals the other function of x. Du by dx is equal to, let's draw the diagram again, sine, cos, minus cos. Okay, I am differentiating sine, so I get cos. So when you differentiate sine kx, you get k cos kx. And k is 3, so you get 3 cos 3x. When you differentiate sine kx, you get k cos kx. And in this case, k is 3. And then you differentiate cos, dv by dx. When you differentiate cos, you get minus sine, so minus 2 sine 2x. Again, we cross multiply, and then you go dy by dx is equal to, where do I start? It doesn't really matter. 3 cos 3x multiplied by cos 2x minus, in this case it's a minus, 2 sine 2x multiplied by sine 3x. And you can look at simplifying it. I haven't thought about it. I don't think you can you simplify this one? No, really. No, so let's leave it alone and move on. One last question. I think it's question 10, and we're looking at two brackets. Y equals 6 minus 3x multiplied by 2x minus 1 to the 5. Which rule am I using? I'm using the product rule. Why? Because it's a function of x multiplied by another function of x. One bracket is a function of x, the other bracket is another function of x, and therefore I am using the product rule. So let u equals one of them, 6 minus 3x. Let v equals the other one, which is 2x minus 1 to the 5. Differentiate the first one, du by dx. Okay, x is to the power of 1, so you end up, the 6 will go into nothing, 0. 6 differentiates to 0. Minus 3 becomes minus 3x becomes minus 3. The power of x is 1, decrease 1, it becomes a 0. X to the power of 0 is 1. Anything to the power of 0 is 1. Okay, dv by dx, and in this case, you can watch my video on the chain rule. I'm going to use the quick chain rule. Just a recap on what the quick chain rule is. 5, you drop the 5 down here. The bracket to the power 1 less, decrease the power. So 5 minus 1 is 4. And then the derivative of what's inside the bracket. And the derivative of 2x minus 1 is 2. So you drop the power, decrease the power of the bracket by 1. So the 5 becomes a 4. And then the derivative of what's inside the bracket. And derivative is basically differentiate the bracket without the power. Okay, so cross multiply again. Let's apply the product rule. Cross multiply dy by dx is equal to bracket 6 minus 3x. 2 times 5 is 10, so let's stick the 10 at the front here, and let's put the other bracket, 2x minus 1 to the 4, okay, minus, we should go plus, but in this case I have a minus sign, so minus 3, and then 2x minus 1 to the 5. And that is my answer. I can take 2x minus 1 to the 4 common factor and factorize it, but yeah, I'm not really interested. And it's nearly half an hour now. It's the end of my video for applying the product rule. I hope you enjoyed it and you have found it useful. Goodbye, and I'll see you in the next video. Bye.